Welcome, everybody. I'm Alberto Ferrari. You said welcome? Wow, that's wonderful. I'm Alberto Ferrari, and tonight, I don't know whether you call it tonight, today, it's very hard here in Sweden to understand exactly the time based on the sun, but we're going to speak about tabular versus multidimensional. The first question that I need to pose to everybody, just to understand who you are before you understand who I am, is how many of you use analysis services? Most everybody. So how many of you have a good experience with UDM? UDM is data modeling in analysis services, old version. So 2008, 2005, 2008, R2. Not so many. Okay. I think you will find something hard. Anyway, the topic of tonight is the discussion between tabular and multidimensional. Tabular is the new version of analysis services that has been out in 2012. Multidimensional is the new name for UDM, which was the technology used in previous versions of analysis services. First of all, a few words about who I am. I am a consultant. With Marco Russo, I founded the site SQLug.se. You can go there and find a lot of the stuff we write, articles and white papers, and a lot of interesting, at least for us, stuff about business intelligence. We do consultancy, problem solving, complex projects, and anything which we think is interesting in the BI world. We write books. We are BI partner, gold partner with Microsoft, SAS Maestro, MVP, MCP, a lot of different names and different technologies. But I don't think you are here to understand who I am. I think you are here to learn something about the new technology which are available in SQL Server 2012. So let's start with a few words, a very few words, about the past. UDM stands for Unified Dimensional Modeling, was born in 2005 with SQL Server 2005. Before, there was SQL Server 2000, but that was just for old guys like me. SQL Server 2005 is probably the most used analytical engine in analytical technology. Then the engine evolved over time. And the idea was to create a unified dimensional modeling, one single model that was useful to create any kind of a business intelligence data model. So by using UDM, you did not have to worry about data sources, from where data come, what kind of connection you had to go. By using UDM, you only had one data model tool that will solve all of your problems. And that was in 2005. The idea from Microsoft was we create one model, and with that we'll rule them all. And so we will be able to solve all the problems of all our customers with just one simple technology. Of course, by following such a kind of idea, there are side effects that you need to worry about. Because if you just use one model to rule them all, you might have some issues. And so, in 2012, after 7 years of trying to use one single model to rule every kind of problem or every kind of data model in the BI world, they decided to change completely the path. Not completely, but to make something different. And in 2012, we can say that UDM is dead. Nobody can no longer speak about UDM because it's a dead word. UDM is no longer here. Now, we call it BISM, BI Semantic Model. The idea of BI Semantic Model, guess what? It's one BI data modeling tool. So it's not that they really changed everything. They just added some feature. They created some interesting tools. They modified their way of looking at information. But of course, Microsoft is Microsoft. So the idea is always, with our tool, you will be able to solve most, if not all, the problems you might have in business intelligence. Now, we have two different flavors of BI Semantic Model. There is tabular and there is multidimensional. Multidimensional is the old technology. In reality, you can think that BI Semantic Model is the unification of multidimensional, which is UDM. So it's not dead, it's just changed its name. It's very common, for example, in Italy, if you are in politics and something is going wrong, you change the name of your banner and everything starts, you're new, and so you can do new politics. So they did the same. They called UDM is now called multidimensional, and tabular is the new kid in town, the new technology that might be interesting or not. Tonight we are going to discover the differences between the two technologies and try to find some reasons to choose one against the other. Now we have two modeling technologies, but one single methodology. The idea of the BI semantic model is that you have several client tools on top of your user will need to use several different client tools. You can Excel, reporting services, Power View, Power Pivot, Power Excel, or any kind of client which is able to query using MDX or using DAX a BI semantic model. And you build using BISM a data model. You have two paths that you can follow. One is the old one, multidimensional. For the ones of you who know multidimensional, this should be pretty easy to recognize. You have multidimensional as a technology. MDX is the programming and querying language for multidimensional. And then when it comes to access data, you have rollup or mollup. Mollup stores data in a proprietary format inside analysis services. Rollup goes directly to SQL Server or to any other database. Here you have all the data sources you can connect that are exposed through the user interface. But now we have a new path, which is Tabular. Tabular is a new technology, is a new way of modeling databases. It doesn't use MDX, it uses DAX, which is a new language, completely brand new language with different features. And when it comes to load data from data sources, it uses two different engines. One is direct query, which is a pass-through to SQL, so DAX is converted to SQL to get data from SQL Server. And the most interesting one is Xvelocity. Xvelocity Memory Analytics Engine is the new name of Vertipack. Maybe some of you know it as Vertipack. I still prefer Vertipack as a name. It's a columnar, in-memory columnar database which powers Analysis Services 2012. And so the idea of BI semantic model is to act as a bridge between client tools and datasets. We don't mind what shape the dataset have. We create a data warehouse using this technology. This is the idea. It's not yet completed because right now you can query a multidimensional data model using MDX, and you can query a tabular model using MDX or DAX. So Tabular, being new, is able to interact with both languages of BI semantic model. But right now, if you have a client that only speaks MDX, it will not be able to query. That only speaks DAX, it will not be able to query multidimensional. So, for example, Power View, which among all the tools is the only one who speaks only DAX, is not able to connect to any multidimensional cube, while all the other tools will be able to connect to multidimensional or to tabular without having to change anything. So, for example, Excel speaks only MDX, but it is able to work with both multidimensional and tabular. So, right now we have two different technologies. Tabular is the new kid in town. I suppose that everybody here knows analysis services. If not, I'm not going to speak about it. I don't have enough time to speak about everything, but tonight we are going to speak just about Tabular, which is the new kid in town. It's the most interesting just because it's new, and so everybody wants to learn how Tabular works. Tabular is based on Xvelocity Memory Engine, which is a columnar database that loads data from databases, compresses them, and stores everything in memory. It runs at an amazing speed, and it lets you create pretty complex data models, as we are going to see later on during the presentation, by using the DAX language. When you compare it with the old technology, the OLAP technology, the multidimensional technology, it's quite always faster. And when I mean faster, it's way faster, amazingly faster. I have never seen something which is fast like DAX is. And it's easier, much easier to use. So basically, if you are new to BI, if you are not so acquainted with the BI world, then learning DAX, learning the tabular way is much easier because you don't have to learn a lot of complex technology that lives in the multidimensional world. If you want to install analysis services in tabular mode, you need to choose it at the instance level. If you have a previous version of analysis services, had only one version, so you install analysis services and you had multidimensional working. You had UDM at that time working. Now, with Tabular, you need to choose at the instance level whether you want that instance to run in multidimensional mode or in tabular mode. It's the same code, the same bits, the same server, but depending from a parameter, it will store data in multidimensional or in tabular mode. And if you want to have both on your development machine, then you will need to install 2 instances of analysis services on the same machine, which is not a bad practice. It's pretty nice. You have 2 instances running, and then you choose whether you want to run multidimensional or tabular. So, what's new and what are we speaking about? The new engine, the Xvelocity Analytics engine, Vertipack, and the new language, DAX. Before speaking about all this stuff, I want to give you a brief introduction about what Xvelocity memory is. So we know it's a columnar database, we know it's an in-memory database. We need to dive a bit more and understand clearly what a columnar database is and what an in-memory database is. So the quick question is, how many of you know what a columnar database is and how it works? Most of you. Whoa, that's wonderful. Xvelocity is an in-memory database, a columnar in-memory database. So I'm going to repeat something for the people who already know, but that's life. It's a columnar-oriented database, and it compresses data. It is important to understand both topics because understanding them will make you design the data warehouse the correct way for Tabular. Unfortunately, or in my opinion, very fortunate, very luckily, designing a data warehouse for Tabular is a different, you need to use different techniques when designing a data warehouse for Tabular or for multidimensional. So if you already have a data warehouse that works very well, you will probably need to change something if you want to make it work in the best way in the Tabular world. Anyway, let's go on speaking about columnar databases. If you have a table like this one containing customers, data, and balance of customers, any kind of column you might have in your databases, you need to store this data on disk. And to do that, you can follow the SQL Server way, which is allocate a page on disk, which is 4 kilobytes of memory, and then store, or 8 kilobytes, I never remember, and store some rows on the page. Once you have finished the space on the first page, you allocate another page and you start writing rows on that page. And then you go on allocating pages from disk and storing rows on your disk. This is absolutely normal. This is the classical way that we all know databases work. And in fact, it's more than 40 years that we store data on disk, on databases using this technology. But the point that are useful to note about this way of storing data is that if you are interested in computing, for example, the sum of or the average of the balance due, you need to load data from disk. And you need to load a lot of information, namely the ID, the name, and all the other columns, which you are not interested into because you are only interested in loading data from the balance due, which is the only column you want to use to compute your average. But this is the way we normally work. In order to improve the speed on specific queries that don't need to load all the tables but just need to load a subset of the columns, we normally create indexes. An index is nothing but a selection of columns from a table which are stored in a more compressed way. Because I can create an index containing the ID and the balance due, and the only difference between the table and the index is that the index will be much more compressed. It will contain many data in the same page because it contains a fewer number of columns. In columnar databases, they simply moved to the extreme limit this consideration. So the idea is to take the customer table and instead of loading it or storing it row-wise like we are doing here, we store it column-wise, where each file contains only one column. So it is similar to having one index on every column. So we have only indexes, we do no longer have the table. ID is one file, name is one file, address is one file, and so on. The big advantage of using this feature is that if I now want to get the average of balance due, that's very easy. I simply load data from this file, and every bit I read is an interesting bit. I'm not reading data which I'm not interested in. I reduce the I/O a lot because I just need to load a fewer number of bytes in order to compute my average. Tables now are stored column-wise, not row-wise. The major drawback of this solution is that if I want to load one single column, life is wonderful because I just need to get data from one column. But it's very hard to find the one report containing only one column. You normally have many columns from the same table that need to be used inside a single report. And in that case, you will need to read data from different columns, and then you need to recreate the tabular version, the raw version, in order to show it to the user. And this will require, of course, some CPU cycle, because you are reading columns and you will need to match them together in order to reproduce something which is useful for the client. Remember that we still use row-wise data when we look at reports and whenever we work with data. So column storage gives you a very quick access to one single column, but requires time whenever you need to materialize rows. What we are doing here is trading CPU versus I/O. We are going to use more CPU to reduce the I/O. In row storages, we did the contrary. We have a very quick access to a single row, but we don't need materialization, but we read a lot of data which is not useful at all. We just read it because it's there. So we trade I/O versus CPU. Since having faster CPU is pretty easy, just buy one, install it, and everything will run faster, while having fast I/O is very hard. It's really, really hard and expensive. It's clearly better to move in scenarios where you use more CPU than I/O because you will get better performances. In reality, if these were the only reasons to use columnar databases, you might wonder why we are not using columnar databases for any database we have in our world. And the reason is that in columnar storage databases, operations like insert, delete, and update are very, very expensive, much more expensive than in row storage databases. So right now, we are using columnar storage only for data which is read-only, which is the case for business intelligence. We don't want to insert data, we just want to read it. If it's time to insert data or to update data and it is very slow, we don't care about it. We have the whole night in order to compute our operation, but we want to be as fast as we can just in reading information. Then there are several optimizations that you can do if you have a columnar database, if you think just at one column at a time. One of them is run length encoding. If you have one column, this is a column containing the quarter for a calendar table, then you can use run length encoding on this column. You see that the same value is repeated many times inside my column, and by identifying the place, the point where the value changes, I can compress this table without any loss of information using a much smaller data set, because I just need to know that quarter one starts from row 1 for 310 times, and then from that point, quarter 2 is the new value. So I just use 2 rows instead of several hundred rows, which are here. So I get a very good level of compression. Of course, it's very good for quarter. It's slightly worse for product ID because it changes more often. So I will create a table which is somehow bigger. And there are cases like the price where it changes so frequently that it is no longer useful to try to compress it. It is far better to store it exactly as it should be, because the original representation will be smaller than the compressed one. And Vertipax does exactly this. It analyzes column by column, and each column is compressed using run length encoding in order to reduce the size. Keep in mind that being an in-memory database compression is very important because you are using memory, and memory, you don't have all the memory you might want. You have an upper limit that you cannot surpass. So memory is very important, and you need to keep it as low as possible. Then, more than doing simply run length encoding, Vertipax does dictionary encoding too. Dictionary encoding is very interesting because if you look back at your quarter column, it contains strings. And strings occupy a lot of space. So if you have big strings in your database, you know that you are going to use a lot of space. What you can do is take the distinct values of the quarter column, create a dictionary that contains just numbers, and then transform all the strings into numbers. The big advantage of this is that, first of all, once you build the dictionary, you can count the minimum number of bits which are needed in order to store one value. And once you know that number of bits, you can encode the column as a bit stream instead of a number of bytes. So since here only 2 bits are needed, in a single byte I will be able to store 4 different rows. So I will get a much more compressed version of my database. And then by using dictionary, I create a database which is completely data independent. You don't worry about storing integer, big int, thin int, or real value, floating point, dates, strings, or whatever you want. Any data type is converted in this way with a dictionary and bit of streams of bit. Once you have created this table containing all the integer values, at that point you can run length encode this table, which contains just numbers. So you create this new version, and if you take both and put together, this is the Xvelocity store. So any column in Xvelocity is made up of dictionary and a run length encoded version of the ID of the table. And this is the reason why Xvelocity compresses very well, just because it uses these 2 techniques. And it does it pretty well. You can expect more or less a 10x compression on a database. So if you have a 60 gigabytes database, it will probably occupy more or less 6 gigabytes of RAM. And compressing in this way, you will be able to host a lot of data in memory. So one of the most frequent questions that I get is how much data can I put inside a single database if it has to fit in memory? And the answer is much more than you can expect. If you have tables which range in the order of several billions of rows, you can still put them in memory on a standard laptop without any problem. Of course, it depends from so many factors that I'm not going to do just marketing and say you can store whatever you want. There are several limitations that you need to obey and you need to design it well, but you can store really a lot of information just in RAM without going to disk. So Xvelocity uses dictionary encoding, which always happens, and run length encoding that happens only if the compressed version of the table is smaller than the original one. Anyway, remember that Xvelocity is in memory, so you have an upper limit which you must obey and which you cannot override in any way. If data doesn't fit in memory, you have only one option, which is buy more memory. No other way. You cannot do anything else, or you can revert to multidimensional or do something else, but the easiest way is buy more memory. If compressed data doesn't fit in memory, you have no option to do anything else. But on the hardware side, when it comes the time to buy a server to run Tabular, to run the new version of analysis services, the way Xvelocity works means that you have to buy a lot of memory, and that memory should be the fastest that you have. Because being in memory, you think that you don't have disks, you just have a CPU and you have RAM. There is nothing else in the middle, just CPU, RAM, and the bus in the middle. If you have many cores that are scanning RAM in order to compute values, you can expect the speed of the RAM to be the most crucial point of your hardware. So you need a very fast memory, the fastest that you have, and very fast CPUs, the fastest you can buy. By mixing them together, you are building probably a gaming machine, which is the best machine you can buy for Tabular. It's pretty normal for Tabular to see this laptop work much faster than any server, just because this is designed for applications, and Tabular is more an application than a server. It's something that runs in memory. Yep.
Yeah. Do you prefer fewer and faster CPUs versus more CPUs?
There is a slide in a few seconds which says fewer CPU, the fastest you can have. Because, it's more complex in reality, but in general, you will never see Tabular running on more than 8 cores. So if you have 16 cores, you're not using them. If you have 64 cores, you are not using them. If you have 8 cores, you will probably see all of them running 100% during most of the time you query Tabular, which is pretty good. It means you spend your money in the good way. The CPUs are doing their work the best they can. If you take 16 cores, you will probably see them not working because they are waiting for RAM speed. They are not able to get RAM from the bus fast enough to scan it. And so you are not spending money in the correct way. And moreover, if you have a lot of cores, you normally have slower cores because you have to trade whether you want speed or you want number of cores. Today's server have a lot of cores very slow. And so they are the worst choice you can do for Tabular. Today laptops have very fast cores with fewer cores and they run much better. It's really, buy a gaming machine and you have the perfect Tabular server. Just drop the video card, which is not very useful. But apart from that, this is the real box you should buy. And the point is that now I understood what happened. I'm missing some slide. Okay, not a problem. There was a slide, I lost it, I have no idea where it is. But the point is that if you look at the appliances, if you look at the SQL Server appliance is something that big because it contains hundreds of disks in order to make them run fast as they can. If you look at the Power Pivot appliance, which runs very well even Tabular, it's something that big because it contains 8 disks just to have the operating system and some data. And apart from that is just RAM and CPU, nothing else. It's it's much faster because it doesn't need disks. And it costs a lot of money less because disks are very expensive. If you want to get very high speed from disks, you need to buy a lot of them. You need to increase the number of disks to get speed. And that's the only thing you can do. On the other side, the good point of disks is that you can increase them as long as you want. If you want more space, just buy more disks. And you can add as many as you want. With RAM, you have an upper limit. Normally, you buy a box, and on this box, you can install 256 gigabytes or 512 gigabytes, but no more than them. And you know that this is your upper limit. You will never be able to go more than that. Today, buying a server with 64 gigabytes should be pretty standard. 128 might be good. But forget about making analysis Tabular work on 8 gigabytes of RAM. You are not going to load enough information. That's the reason why I had to buy a notebook with 32 gigabytes of RAM, because otherwise I was not able to run good Tabular demos. And from the data modeling point of view, all what we have seen up to now means that you will probably need to change the way you store your data. For example, since Tabular is data type independent, there is absolutely nothing bad in storing big strings inside your fact table. If you have 1 billion of rows and you have a string which is 20 characters, you would never think about storing that string in the fact table because it's simply stupid. You store an integer and then you use the integer value to point to a dimension. That is true for SQL, that is true for multidimensional, but that is false for Tabular. Tabular works much better with a string directly stored inside the fact table because it will take care about converting it into integer and then mapping it using the dictionary. So if you have something like junk dimensions, you can forget about them. Junk dimensions are the hell for Tabular because you are trading several small columns with a small number of distinct values for one column with a lot of distinct values. Many columns with fewer distinct values work much better than one column with many distinct values. So junk dimension is something you should forget in Tabular. And the general dimension are dimensions that contain a lot of different distinct values in the fact table, like, for example, the order number or columns like them. And in this case, it is better to split the column in two. Think, for example, you have the order number, which is order year and then order number. If you split it into two, then you will have order year, which is the same value for a huge number of rows, and then order number, which has a lower number of distinct values. And by doing that, you will save a lot of space in your database. In order to do that, you can simply split, for example, if you have a string of 10 characters, you can split in two, and you are happy with that. You have two strings of 5 characters, each of one uses a smaller number of distinct values. And if you have a number, you can simply use divide and modulus in order to reduce the number of distinct values. This has a big impact on performance when querying data. If you are going to query the complete table, this will really create you problems. But if you are just going to query a small subset of values, it runs very fast. And from the space usage, there is a big difference. This example is a database containing 100 million rows of one number. If I store just 100 million rows on memory, I will use more or less 3 gigabytes. But if I split it into two, so 2 columns, each one is 10,000 distinct values, then the size is more or less 10 times less. And since it's memory, it is very important to reduce memory in order to be able to store more information on the same data set. Then going from 2 to 8, we are not going to gain a lot. But splitting into 2 is already a very good advantage. From the storage point, of course, you see that from the CPU point of view, splitting means using more CPU, both to process and to query. I don't have query numbers here, even because here we have only one core which is being used. Here we have, for a sustained time of time, 8 cores running all together, because they need to run together in order to compress more efficiently data. So you reduce the memory footprint, but of course you increase the cost in terms of CPU. But this is something that you can increase. You can buy faster CPUs, so it's not a problem. Decreasing memory is much more important. Okay? This was just to give you an introduction about what the new Tabular engine is. Now, I want to spend some time. We have spoken about Xvelocity memory, the new engine, how it works, or some insight in how it works. Now I want to spend a few more time speaking about DAX. DAX is the new language of analysis services. It's completely new. It has nothing to share with MDX, with SQL, or with any language you might have seen before. And since I don't have time to teach you DAX, we don't have time to explore all the capability, all the possibility of DAX and to understand how it works, I decided to do something completely different, which is we take a scenario, a customer. Our customer is AdventureWorks, of course, so he sells bikes all around the world, and they already have a data warehouse built with dimensional modeling from Kimball, so they're good guys. They created the data mart, and they come to me and ask, okay, now that I have my data warehouse, it's a relational data model, I want to build on top of this data warehouse an analysis services solution that will solve all of my problems. So I will start playing with my data on my data warehouse. And so I take a quick look at the data warehouse. It contains date, customer, product, categories, geography, a single fact table, very well designed star schema. And so it's a pretty easy one, nothing strange and nothing really complex here. And I start the project. If I was a classical developer, that means I don't know about SQL Server 2012, I start Visual Studio, I create a solution, I start creating measure groups and create dimension, I create attribute relationships, deploy it on the server, and do all the stuff that I think you already know how to do. So I'm not going to demo anything about multidimensional, but since, how many of you are consultant? Most of you. So you know that before you start putting your fingers on the keyboard, you have to go to the customer and say, hey, wait a moment. Before I start working, I need to be clear on the fact that you will need to pay me for the work I'm going to do. And since it's a very classical data warehouse, I think that, okay, 4 dimension, 1 measure group, I will take 1 day of work in order to build everything, and I will ask you 500. 500 doesn't mean anything, of course. It's not dollars, it's not euros or USD or whatever you want. It's just a number. So let's say that 1 day is worth 500, whatever you like. And the customer says, well, in 1 day you are going to build my solution, so I'm willing to pay it. And in the meantime, while we think that somebody is building this solution, we're going to prototype everything using DAX just to look at whether it is easier or harder to create a prototype with DAX. Since we are speaking about DAX, we are not speaking about analysis services right now. I'm not going to use the Visual Studio to build everything. I just deploy everything using Excel. I install Power Pivot for Excel. How many of you don't know what Power Pivot for Excel is? I love you. And I start loading from some data. So I go to SQL Server, I connect to my demo machine, which is, by the way, this machine. I connect to AdventureWorks, and I select some data. I have already created some views. These views don't do anything but project a few columns from the table from AdventureWorks. So they don't do any kind of processing, but I don't want to have 100 columns for the product table. I just select a fewer number of rows of columns, so it is easier to load data. So we want the calendar, we want categories, customers, products, sales, and I think it's enough. I don't remember whether these are the tables we were speaking about, but we can start playing with these and look at what happens. Now, the data has been loaded inside my model. I can see a data here, but I'm interested in the data structure because I need to create relationships. So I have my calendar, categories, products, sales. Okay, this is the fact table. The product key points to product. Subcategory points here. The order date points in the calendar. And the customer, we should have a customer key somewhere. Customer points here. So we are simply creating the data model. It's a snowflake, but we are not very worried about this. And once we have done it, we simply go back here. We have our dimensions. We don't need to set up anything strange. We just need to create some measures in order to have numbers which can be computed. We can go here and say, I want to sum the sales amount. I want to sum the product cost. And we are more or less up and running. We can test it with a pivot table by creating a new pivot table. And we take, for example, the year. We put on the columns, the products. We can put the product color here. And we can go to the sales table and say, oh, I want to see the sum of sales amount, which we put here. And the pivot table is already working. Now, of course, this is not very complex. This is pretty easy. This is pretty simple. But it's already very nice to see how fast it is. It's a matter of 5 minutes to create a simple data model on top of a data warehouse. So we are not going to take a day. We are very happy. And the customer says, wow, I'm already looking at numbers. Now, I don't know what happens to you when you go to customer and deploy something on their server, but whenever I finish my project and I publish it to my customer, then he says, oh, well, that's very nice. Now I see that my project is working very well, but now I would like to have something more. I want to have a new feature. I want to have a new measure. I want to see new numbers. And the first thing that they say is, oh, now that I see numbers about sales, I want to count the number of customers that I have over time. And this is not very easy to do. Oh, well, it is very easy indeed, but it's something that you should project in advance because you have created in customer as a dimension and you want to count from a dimension, which in Kimball theory is awful. You cannot count a dimension, you just count measure group. So you create a measure group on top of your dimension and you create a measure that counts that measure groups. It can be done, of course, and it's pretty easy, but it needs some time because you need to reopen the project, modify something, and then deploy it on the customer. The customer is happy because everything is working fine, and so he says, that's fine. I approve the project, move on. In the meantime, we do the same using DAX. And since the customer wants to count the customer, we simply go to the customer and we say, oh, we want a new measure. Here in Tabular, there is no distinction between measure groups and dimension. A table is just a table, nothing else but a table. So if you want to count the number of rows in a table, you create a measure, you call it number of customers, And the formula is count rows customers, not very complex to author or to understand. Count the number of rows which are in the customer table. Yes, we have to do something more complex. We say it's a number, you use thousand separator, and we don't decimal places because it's just a count. And then we remove it. We remove the sum of sales amount. We remove the color from here just to show to our customer that everything is working in the correct way. We take the education, and now you see we are counting customer without changing the original database. Something that I want to tell you right now, because we are going to see it further, is that all the update and all the modification that I'm going to do on this data model will not require touching in any way the original data source, which in my opinion is one of the coolest features of Tabular. It is so fast that it can normally work without the need to modify the relational model you already have on your customer side. So we have done our first solution, and the customer says, oh, sorry, I need to go back here. The customer looks at number and say, they are very cool, they are very nice. I see numbers, the numbers of customers, but I'm wondering, why is it the same number over time? I didn't have the same number of customers over time. The number of customers changed over time. And the answer is pretty easy. I'm not counting the customer who bought something, I'm just counting customers by taking customers as a measure group. And doing that, I have no relationship with the calendar table, which is absolutely expected and normal, or at least this is the way BI professional thinks when they speak with customers. But the customer, my customer Adventure Work, says, yep, that's fine, but I didn't want that count. I want a different count, which is the count of buying customers. And now, with multidimensional, we start having problem because buying customer is the distinct count of the customer key on the fact table. And computing the distinct count in multidimensional, it's not easy. You need to create a new measure group. That measure group should be dedicated to the distinct count. You create a distinct count measure. And if you have a small database, your work stops at that point. If you have a big database, you have to pay attention of a lot of different topics. During processing, an order by will be sent on the fact table, so the fact table will be sorted by that column, which is a pain, and you will probably need to partition it using the number of CPU and a function that will correctly create the number of threads which make distinct count run fast. So it's far from being an easy task. Creating distinct count efficiently in analysis services means spending a lot of time to create correctly the distinct count. And even if you do all of that, they will never be fast. If you have several billion rows in a table, don't expect distinct count to be fast. They are amazingly slow. Or, say it in another word, when we speak about minutes to query a distinct count over several billion rows, it's pretty normal in a multidimensional. So, since it is not an easy task, we need to ask for a lot of money to do that, because we need to create a new measure group, partition over a hash function in order to increase speed, and then optimize processing, because processing will mean order by on the fact table, which means create indexes and create data structure that will make this processing feasible. We need to get a lot of money to do something easy like a distinct count. But at that point, the customer has no choice then to say, okay, I'm going to approve even this because I want to have the number of buying customers. In the meantime, of course, we are going to do that in DAX. And in DAX, creating a distinct count on the customer, it's not very hard. You need to go there, add a new measure, which is buying customers. And buying customer is pretty easy to write because it's distinct count of customers, not customers, sorry, but of sales customer key. And then again, we have to say it's a number, use thousand separator, remove decimal point, remove number of customer, and this is the distinct count of customer over the fact table. You don't have to do simply nothing. You just use DAX to author the formula. And if you paid attention to how DAX stores information, you understand that computing distinct count is very fast on this columnar database because it already works very well with distinct count due to the way data is stored in after run length encoding. So computing distinct count is incredibly fast. It runs over a table with billions and billions of rows in a matter of 1-2 seconds, no more. Yep.
Question: you define the measures right now in Excel, not in the Power Pivot. Is that the case?
Yep. Just because this is the Power Pivot field list. This field list is not the original field list. It's the one that Power Pivot pushes inside instead of the one which is available in the standard pivot table, which is here it is. This is the pivot table field list, and this is the Power Pivot field list. I always get scrambled with Power Pivot and pivot table, and they move power wherever they want it.
Those measures be available in the Power Pivot as well?
Pardon?
Can you see those measures in the Power Pivot?
Absolutely, yep. If you go in the Power Pivot window, we should be somewhere here. We define it in the customer, and we have it there. Number of customer and by customer. It's the same. You can define them here or there. It's the same. Okay. We have solved the first problems of our customer, and the customer is getting hot. He says, oh, while you are here, you have created my measure that computes the buying customer, and now I want to have a new measure, and that measure is the new customers. I want to have for each month the number of new customers that I had for that month. And now a question: how many of you know right now how to solve this scenario using analysis services multidimensional? And the problem is that I don't raise my hand. Whenever I have to face problems like this one, that is compute the number of new customers or of old customer or of returning customers who bought something that didn't buy for some time and buy something new for after some time, I normally go to the book I write, searching for the solution in order to start building that. And this happens whenever I have to find this solution because they are so complex. Basically, what you need to do is to create a snapshot table that says for each customer and for each day whether that day that customer was new or not. So you have a number that you can aggregate, store it into the model, and query. This means having huge data structures in order to solve something which is pretty easy. From the customer point of view, new customer is just a number, something that you should be able to calculate pretty easily. So, since we need to search on the blog and to search somebody who already solved this problem, we are not going to charge money for that, but we are going to try to do the same with DAX. And if you think in the DAX world at the new customers, it's not all that complex. You can go here, create a new measure, and how would you define new customer? A new customer is somebody who has never bought anything before and is buying for this year for the first time or for this period in time for the first time. So it's not very easy to author in DAX 2, but it's not very complex. You simply have to calculate the number of customers, so count rows of customers. But you don't want to count all the customers. You want to count only the customers that have this specific condition. So you need to filter the customers and find the ones where, find the ones who never bought anything. To say that the customer never bought anything, you use count rows of sales. Count rows of sales anytime before the 1st of January of this year. So we filter all date, all calendar, finding filter all calendar where calendar full date is less than minimum of calendar full date. Sorry, but I need more real estate. And this result should be equal to 0. So he never bought anything before now. And we want to add one more condition. That is calculate count rows of sales is greater than 0. Okay, if I am lucky enough, whoa, it never happened. Really, I delivered this session a lot of time, never happened to write it correctly the first time. We need to specify everything here. Click OK, remove buying customer, and this is our new customer formula. We didn't have to change anything in the data model, just write some DAX code. It's not easy DAX. I'm not going to say that writing that DAX code is easy, but believe me, the only difference between you and me right now is that I know DAX and you probably don't have a good experience with DAX. But it's not longer than any SQL query you are used to write. And it's not more complex than a SQL query with a couple of subselects. You just author the formula in a different way. And you trust the fact that it will work at an amazing speed with huge tables, just because it's in memory and it is incredibly fast. So we have solved our, not the last problem, but one of the most complex problems from the data modeling point of view you might have. And it was pretty easy, not very hard. I'm not going to see bending, it's boring. I want to show you ABC analysis. How many of you know ABC analysis, Pareto principle and ABC analysis? Just a few. The basic idea of Pareto principle is it's a technique to focus on your core business. Think that you are Amazon, you are selling books, and you have to decide whether you want to keep a book on stock or not. Do you want to spend money to have this book already always available for all your customers? It's a decision you have to take, and a lot of money depends on how good you are in taking this decision. ABC analysis says divide your databases, your product table, into 3 clusters. First one is the product that creates 70% of your revenues. Class B is the remaining 20%, and then Class C is the remaining 10%. So your core business is product in Class A. Class B is somehow interesting. Class C is something you should not care about. And the idea of the Pareto principle is that just a few products will be in Class A, some products will be in Class B, but the vast majority of products will be in Class C. So from the Amazon point of view, it means that the books in Class A will always be available, and they will ship them as soon as possible because they are getting a lot of money out of them. Class B will be 3 to 5 days before I can ship it, so I'm not going to spend money. I will store them somewhere very far. And Class C is ordered on demand. Even if I lose half of the orders of products in Class C, I'm not losing money. I'm just losing 5% of my revenue. So I know that my core business is products in Class A. Of course, I want to compute the product class as one of the attributes of my dimension, because I want to slice by using class of the product. And here I'm looking at customers and the kind of products they buy, Class A, B, or C. So I want to compute this value before data enters my analysis services database. I cannot compute this in MDX. I need to compute it before data enters my database. And if you think about how complex it is to compute this value in Excel it is pretty easy. Because you simply take the product, the total sold for the product, you sort it by total sold. So the first one is the most important one. Then you compute the incremental value. With Excel is really a snap because you take the previous value plus the current one, and so it increases over time. And it's a running total starting from the first product and always increasing. Here you place the grand total, which is the grand total at the bottom, so the total sold from all the products. You compute the percentage which is incremental divided by grand total, which means that the first product is responsible alone of 4% of my sales. The first two products together are responsible of 7% of my sales, and so on. This number increases. It's always increases because it's a percentage of incremental against the grand total. I know that I am in class A if this number is below 70. When I reach 70, then I am class B. All the products I'm not selling enough of them to think that they are really important. And then when I reach 90%, I am in class C. So these are the products I'm not interested in. In order to compute that in Excel is very easy. If you want to compute that in SQL, it's far from being easy. And it's a very nice exercise if you want to try it. You need to sum the amount and group by product and create a temporary table. If you don't do that, queries will be simply impossible to write. And once you have done it, you need to compute the running total using SQL, which is far from being easy. You need to compute the total running and compute the percentage. Once you have computed this percentage, then you can update your product class, and only at that point you will be able to process your database. So it's a nice exercise. It's pretty hard, not very easy to author or to write. And moreover, you are duplicating the business logic in the cube and in SQL, because probably you will have some business logic to compute the total sold for one product or for many products. And since you need to compute this value before processing the cube, at this point you are duplicating the business logic, which is never a good idea. There is a smarter way to do that. Since MDX is very fast in computing the set of products that belong to class A, or the set of products that belong to class B, or the set of products that belong to class C. The point is that it is able to compute this value very quickly once data is inside the cube. And we say we want the data to be available before data enters the cube. So what I found as the best solution is to process the sales cube without ABC analysis, then run MDX queries on the sales cube, so you get the sets of products in class A, in class B, and in class C. You store this product ID inside the table, so you update at that point the product table, and you reprocess again just the product dimension. So you don't need to reprocess the complete cube, you just reprocess the product dimension. By doing it this way, you run pretty fast, and the customer is pretty happy, but you need to do a lot of work in order to solve the problem. Of course, as always, we are speaking about big databases. On a small database, this shouldn't be a problem. You can process twice the database, and everything works fine. And you have to ask for some money for that. So 2 days to handle double processing and all the complexity of ABC, and then compute and store the cluster 1 day, so just to have some numbers. And clearly, the customer says, that's fine, I'm going to approve everything. In the meantime, we try to solve the same problem using DAX, and we need to go to the Power Pivot window this time because we are going to use calculated columns. And let's try to follow the Excel way, the easiest one. The first thing that we need is to compute for each product the total sold, which is calculate sum of sales amount. Okay, by using calculated column, I am storing inside the column of my database the result of a computation. Total sold seems empty, but we can easily sort from the largest to the smallest, and you see that it contains some values. So this is the total sold for the first product, and by sorting the correct way, this is my top product. Then we need the running total. The running total means that for each product, I want the total of all the rows that happen to be before it. And this is not very easy to write, but it's not very complex. It's one of the classical patterns in DAX. It is simply equals to sum x all products, not all products, sum x filter. We don't need all. I have to pay something because the first formula was working at the first time, and this is something that I don't remember and I need to write right now. I want to filter the products, and I want all the products where products total sold is greater than earlier products total sold. What I'm basically doing here is to iterate over products, searching for the one who sold more than me. I'm computing this row by row, so for each row I search the number of products that sold more than me, and for them I sum the products total sold. Let's see if I am still lucky enough. No, I change it to English. I got the point, but I would really like to close one parenthesis, nothing more complex than this. And done some X filter products earlier than, where is the product?
Sit on the bottom row, the table name.
Pardon?
Yes. Table name on the product. The last time, product.
Products. Thank you very much. Okay, we have the running total. And you see, running total is always increasing, starting with the first number and then increasing. Clearly, it's not working because we have data sorted, because we can sort data the way we want. It's not going to change in any way because of course it is computed in a way which is completely independent from sorting. Okay, I just keep sorting because it's very easy to read data if we keep it sorted. Now we have our running total. We need to compute the percentage, which is running total divided sum of total sold, and this is pretty easy. It's just a number, and we want to format it in the correct way. It's a percentage. Now you see that the first product is 4%, then 820, and so on. So each product has a different percentage. When it's time to compute the class, it's pretty easy. You simply, this is incremental percentage. When it's time to compute the class, you simply use if incremental percentage is less than 0.7, then we are in class A. Otherwise, if incremental percentage is less than 0.9, we are in class B. Otherwise, we are in class C. Should be correct. And here we have computed everything. Okay? I don't know whether you have ever created ABC analysis on one of your solutions, but believe me, it normally takes several days just to think, start, work on the project, and build something useful. By using calculated columns, this is solved in a matter of minutes, because it's a pattern. It's something that you learn how to do, and once you know the technique, you simply apply to all the customers that you want. So doing something like ABC analysis using calculated columns creates really complex problem, makes really complex problem much, much easier. That means you can sell consultancy much easier because it doesn't cost too much. It's just a matter of making something very quickly. And it's up and running. It's not going to spend any time during query time because everything is computed at process time and then stored on the database. It's a calculated column, so being a calculated column, it's working here. At this point, the customer is pretty happy. He has all what he needs. We have created a lot of different features, but he says, that's nice. I have seen how to use Power Pivot. It's pretty cool. You can use Power Pivot and Excel to compute everything, but I haven't asked you a Power Pivot workbook. I asked you for an analysis services database, which is something slightly different. I want to add security. I want to make it run on the server. I want to add all the features of Tabular. And we still have to do some work in order to take this prototype, which, by the way, the cool part of this prototype is that you can build it with your customer. So the customer asks you for numbers and you compute them on the fly. And he sees the numbers, and if something is not correct, he will tell you, oh, this number is not what I want a different one. And you play with him. Since you don't have to spend time with Visual Studio, you are just spending time with Excel, and the user knows Excel, know how to use Excel, and is pretty easy to involve him with Excel. But we are just doing Power Pivot, and the customer didn't ask you as Power Pivot. So what we need to do is to close the Power Pivot window, save this workbook somewhere. We can save it to C temp and call it Stockholm. Okay. I always forget to save the workbook during demos, and once in some time it will happen to crash everything just before the end. And then we open Visual Studio, and we say, oh, we need to create a Visual Studio. Let's create a new project, and we choose Import from Power Pivot BI, and we call it Stockholm. Click OK. It's already pointing in C.temp. This is the only place from where I create databases. It gives an error just because of security, but it is now reading the Power Pivot workbook, reading all the metadata which is inside my database, and all I need to do is reprocess all the data in order to see some information inside my Visual Studio solution. Now we are no longer using Excel, we are using Visual Studio. So this is Tabular, this is Analysis Services, and in order to deploy it, we just need to go to Properties, Localhost Tabular. It's already called Stockholm, so we can simply deploy it. Of course, we can add the security, we can add okay, we should deploy it. It's deploying on the server, and now, if we go to the server, of course, we are going to see inside the databases our Stockholm database that contains calendar, categories, customer, product, and sales. The only point that we need to add security, we need to add probably some nice stuff, but some automatism in order to process everything during nighttime or something like that. But you can create a complete prototype, and once the customer is happy, you simply deploy it on Analysis Services by opening your prototype without spending time in Visual Studio. So we did exactly what the customer asked us, and probably if we were to start using Visual Studio, at this time we were just opening Visual Studio and trying to create something new. So the idea is that we have a simple relational data model. You might have noticed that we didn't use dimensions and measure groups. We just used tables and computed over tables without any problem. And by using table, relationship, and calculated columns, which in my opinion are the most interesting feature of Tabular, we have created all calculation, and we have created something which is not very easy. It's a pretty complex scenario, it's a pretty complex data model, but we made it very fast, at an incredible speed, both in query time and in development time. At this point, if we were to solve the problem with UDM modeling, the customer should have waited for 9 days, more or less, and 4,500, whatever you want. And if you think at the kind of work we have done, this is not unrealistic. It's pretty a standard price that you can charge in order to get all this work done. We have used Tabular to solve the same problem, and we have done everything in 1 hour. We just need to deploy on the server, add security, do something less. And at this point, you can go to the customer and say, you need to pay me 400 because I worked for 2 hours. I don't know you, but my customer normally answers, what? You want 400 for 2 hours? I normally pay 500 for 1 full day of work. So I'm not going to pay you 400 just because you spent 2 hours of your time working on a simple workbook file. And I had an answer for that it is, oh yes, but I had to spend a lot of time learning DAX, so you need to pay me for the time I spent learning DAX. Believe me, it never worked. Whenever I tried, they never believed me. So I decided to go to another answer, which is, you save 90% of your time and of your money, because I gave you a project in 10% of the time other people required you, and you are going to pay 10% of the full price you had to pay with that people. Then don't worry about how much money I'm gaining. That's a problem of mine, but you are getting a lot of advantages just because I know my work. And at this point, customer says, oh, that's nice, so I'm going to pay 400 just because you are solving me my problem. So, to go to a conclusion, because I think we need to eat some, I think you need to eat some pizza. He's already arrived, so we need to eat pizza. I need to taste the Swedish pizza. What should you do next? Learn DAX. Seriously, learn it. DAX is not easy. DAX is it looks very easy, but it's very good in hiding complexity. You look at formulas, everything seems to work, they seem very natural, and if I write them, you say, whoa, that's very easy, I will learn it in a couple of days. Don't believe it. It will take a lot of time to learn DAX because it's very complex, even if it seems very easy. So you will need to spend time, take some weeks before you start really using DAX. And I think that tabular DAX are not the solution of all the problems. I'm really passionate about DAX, but I don't think that DAX is the solution, the one that will solve all of your problems. It's not the only way to go to the future. Multidimensional is here to stay, and knowing MDX is very interesting. And it's not the only solution. But for more or less 85% of the project you probably are working on, DAX would be much better than MDX. So the projects are there, you're already working, don't touch them. But if you are going to play with new projects, chances are that you are going to make them easier and cheaper by using DAX instead of using multidimensional, if you spend time learning it. And customer will love it. We love DAX, and probably will love you if you are so fast in creating projects for them. That said, this was all the nice part of Tabular. Then there are scenarios where Tabular is not so strong. So in the next part of the presentation, we are going to spend time and look in reality at the differences between the two engines in order to say, okay, that's very cool, I can create very interesting project, but what happens if I have several strange scenarios? And in that scenarios, you will see that Tabular might be very strong or very poor. So you will have weapons to decide whether you better use one or the other one. I think we can let the pizza come in.